Producers and distributors of Tech AV training material welcome you to the third module in a series entitled Programmable Logic Controllers. In this module, we shall be overviewing PLC hardware and ladder logic, how the PLC receives input signals, how it uses these signals to make decisions, and how it outputs these decisions as action steps to control working devices. Remember that your workbook contains the relevant resource material to be studied in conjunction with this module, so please read the resource notes before viewing each section of the program. Before we begin this module, let's review the important points we learnt about in Module 2. Firstly, we discussed input devices and how they gather information. We identified two specific types of input devices, namely digital and analog. We explained that both types are classified as information-gathering devices. However, digital devices send messages as simple on-off voltage signals, whilst analog transducers transmit dynamic output voltage signals which change according to the physical condition they're measuring. We also examined two-state output devices that receive a simple yes-no message from the logic circuits, which switches them either on or off. Finally, we examined the operation of three key logic devices, namely a relay, a timer, and a counter. Then, using a relay ladder logic diagram, we explained how input, output, and logic devices are combined to create the automatic control system. We begin Module 3 having placed our block sorting machine under PLC control. This is how the PLC logic diagram and power flow of the block sorting machine appears on a computer screen. Notice that the PLC ladder logic diagram is very similar to the conventional relay ladder logic diagram, and it is these similarities which make it easier to understand the fundamentals of PLC logic. The input and output devices generally remain the same, and the PLC simply replaces the relay logic controller. So, if you have understood the basic principles of relay logic, you will have a good idea how PLC logic operates. Let's continue then by discussing the input and output circuitry of a PLC, which will explain how the PLC communicates with the external devices connected to its inputs and outputs. Unlike electromechanical relays, the PLC is a very low-power, solid-state device, easily damaged by high voltages and currents. Therefore, all PLCs incorporate electrical isolation and conditioning circuits at their inputs and outputs to enable them to communicate safely with the external environment. These interface circuits are either contained in modules or form an integral part of the PLC itself. The choice of input and output modules or the type of PLC depends on the application, whether the signals are analog or digital, and the number of input and output points required to control the system. One of the big advantages of a modular-based system is that the PLC can be tailored to the application. For smaller control systems, like our block sorting machine with its 4 inputs and 5 outputs, this compact fixed I/O type PLC is more than adequate. It has 10 inputs and 8 outputs, and is suitable for controlling digital input and output devices. Now let's see how the external devices are wired to the PLC. All connections to and from the PLC are made via these terminal blocks located in the modules or on the PLC enclosure. This strip accommodates all the input devices, and it is here that we wire our information-gathering devices, the start and stop switches, and the 2 limit switches. Notice that each input point is clearly marked with a unique reference or address location, so the logic knows where to look for the input voltage signal. This typical wiring diagram shows how the input connections to the PLC are arranged with one input terminal allocated for each external device, and a common return line to complete the circuit for each input. In a similar way, working devices are connected to the PLC through an output interface or module. And just like the inputs, each output point has its own unique address location, so that the processor knows where to direct its output signals. Once the I/Os are connected to the PLC, all the hardwiring is complete. So, let's present our system as a two-dimensional model according to the 3 stages of automatic control. On the left-hand side of the PLC, we have positioned the input or sensing devices, each one ready to send an on-off voltage signal to a specific address location on the input terminal block. And to the right of the PLC, we have placed the working and indicating devices, each wired to a specific location on the output terminal block. After the break, we'll examine the layout of a typical PLC ladder logic diagram.